Good morning. Good morning, everyone. Thank you for joining us for this webinar on career in data science. So we are still waiting for some more participants to join, and it will take maybe 2-3 minutes more. So after that, we can get started. Thank you for your patience, and we will wait for another 2 to 3 minutes. So let's get started. So again, good morning all. Thank you for joining us for this webinar on career in data sciences. So let's look at the agenda for this webinar. This webinar will have two sections. In the first section, we will start with understanding what data science is, what is the intuition behind data science. We'll then move on to formal definition of data science. While we discuss definition, we'll also look at core constituents of data science, its applications, or you can say outcomes of applied data science. We'll then move on to data and what is the typical data science life cycle and what are the different tools people or we can use to achieve outcomes out of data science problem. And we'll cover artificial intelligence and machine learning and deep learning under the umbrella of artificial intelligence. In the section 2, we'll look at which sectors in industry using data science, what these sectors expect from data science or how data science is helping them to succeed in some decision making process. We'll later talk about roles of a data scientist in different sectors so that when you join any of these sectors as data scientist, you have some idea what is expected from you. Though roles and responsibilities or the job description may vary from these tasks, which we'll talk about in this webinar, but it is good enough to give you a flavor of what is expected when you join any company as data scientist. So let me give you a brief introduction of mine about education. I have done my master's in thermal science in mechanical department at IIT Delhi. I was an associate member in Institution of Engineers in mechanical department. On my professional front, I have a 6+ years of experience with G at different roles, engineer, lead engineer, senior data scientist, and presently I'm working with senior engineer data science at Eaton. On data science projects, I have been associated with computer vision, image processing, object localization, detection, classification using deep learnings like convolutional neural networks. And I have been associated with machine learning algorithm development for forecasting. So we'll have a moment here to digest some of the things in agenda. Give me a moment. I'll just trying to put my PPT in slide mode. I hope my PPT is in slide mode now. Any response from audience? Can you see my PPT in slide mode? Okay, sorry for interruption. I was just trying to put my PPT on slide mode. I hope you all can see my PPT in slide mode. And let's go ahead. So let's start with a small quiz. I'm just displaying some of the words or terminologies related to data science, like data, power of data, data science, machine learning, deep learning, artificial intelligence. So, are you familiar with these terminologies or words? I think you would be, because these words are everywhere. News, career talks, innovation forums, conferences, everybody, every place is like full of these words these days. So, if your answer is yes, definitely you will get to know more of it after this webinar or during this webinar. And if your answer is no, then your answer will change to yes with much better understanding of the subject and the applications. Moving ahead, so again, some question to start with. Have you ever tried guessing your marks in an exam or in next semester? Just give a thought. Just give a thought. Like in the past, have you ever tried guessing your marks in an exam or in a semester? Or maybe you have tried guessing next month expenses. Or maybe have you ever tried what would be my total savings if I keep on accumulating with the present rate as I'm doing now? Or maybe which this example I have tried personally, like riding my bike. I have tried guessing mileage of my car. So maybe you must have tried any one of these things in the past. And if your answer is yes, then you are already data scientist. You are already doing that. So jokes apart, how could you do that? So let's try to uh, see that what had happened after that when you tried, guessing that or just judging some of the things. So here's the answer. So remember that first slide, some terminologies, yeah, data. First piece from the slide one. So I just talk about it a little bit and later. And now just going back to questions which I put in the previous slide. How good was your guess? 30%, 40%, 60, 80, or you never bother about checking how good your guess was at that point of time. But this, I think you would have thought about it, that how could I have improved my guess? So definitely there are ways you could have improved your guess. Let's try to find out that answer. So is the power of data. Second piece from the slide one. So I will give you more about it in the coming examples. So going back to the monthly expenses example, assume you were to guess November and December 2019, which is festive time would be coming, and you were to guess expenses in the month of November and December. So there could be two scenarios here. Scenario one, you have no data. So you don't have any record of expenses happened in month of, like, would be happening in month of July, September, August, October, previous to November and December months. Maybe from the previous 2018 years, November month or December month, you don't have any data in scenario one. So how can you do that? How can you guess your, or how can you, make a judgment on what kind of budget you would be keep, or you should keep in your bank to meet these expenses on month of November, which is festive season. Diwali, New Year, Christmas, all these festivals are there. Any guess? Any guess from audience? How can you do that? Okay, it's very simple. Go with gut feeling and guess, right? We do that. We do that in many situations, many circumstances when we don't have any data. We just go ahead with our gut feeling and guess any number. And in scenario two, you have data like November 2018, December 2018, Jan, Feb till October. And now somebody is asking, or you are yourself is trying to guess expenses for the November and December month. So how can you do that now? Go with the data and predict. So here is, in the slide there is a catch, right? When you don't have data, you just go ahead and guess anything. But when you have data with you, you go ahead with the data and predict. So data is differentiating between guess and predict. So actually data is moving this process of guessing to the process of predicting. And definitely, when you have data, your guesses or your prediction would be much better than simply guessing. So let's spend some time on understanding that what is data science. You all know the answer, right? Okay, no problem. So this is the formal definition of data science, and source of this formal definition is Wiki. So data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Confused with words? Okay, no problem. So we'll try to understand this, what this definition says, and what all these different words meaning here. So coming to the first big word in this definition is multidisciplinary field. So what is that? So when you say data science, it's a multidisciplinary field where statistics comes into play, maths, computer science, information technology, business domain knowledge. So what is this business and domain knowledge? We know subject statistics, maths, computer science, information technology. What is this business and domain knowledge here in data science? Give me a moment. Okay, I have got one feedback about my slides are not moving ahead. I have got a feedback on my slides are not moving ahead. So let me just give a try back on these slides. Just give me a moment. I'll just give a try. I have got a feedback that slides are stuck. So I'm just so let me check back with audience if now it's moving. Yeah, Himanshu, is it fine now? Can you check? Okay. Okay, okay, sure, sure, sure. So, the feedback was the slide was stuck, so it's not moving ahead or what? Huh. Okay, okay. So I need to remove from slide mode and go ahead, right? Okay, okay. So just let me know. I'm just in that mode. One second. Sorry, one second. So I'll just try to increase the. I don't know what is happening actually. Okay, now can you check? No, it's working. It's moving ahead. Not in slide mode now. Yeah, it's moving now. Okay, then I will continue this and like this only. Okay. Hello. Sorry for interruption here. Sorry for interruption. There is some technical glitch while presenting or while uploading this page. So I'll just go ahead and try to work in this mode itself. So we were discussing that differentiating the data can differentiate your decision through guess and prediction. So going ahead, we discussed definition of data science, and then we were discussing multidisciplinary field data science. So in that, when I talked about there are statistics, maths, computer science, information technology, internet of things. So we all are aware of these subjects. So what is business and domain knowledge doing here when we talk about data science? So I will just try to spend 2 to 3 minutes on that, because this is a very important aspect of data science problem. So assume you are solving a data science problem in manufacturing plant or manufacturing industry. So what happens that then this business and domain knowledge is coming from that sector, manufacturing sector. So this in the data science problem, business or domain becomes manufacturing. So assume you are solving a data science problem in retail sector. So this business and domain knowledge is coming from the retail factor, because data science can give you important insights about that process, or the insights coming from the data. uh, but when you use this insight with the business or the domain knowledge, then the solution is complete. Without business or domain knowledge, if you try to use those insight, it won't give you the desired results or the desired outcomes. So business and domain knowledge becomes a very important part of data science. So, and when data science problem is being solved, so one or more disciplines may take lead and others are secondary, or vice versa. So some of the times you will see that this business and domain knowledge is taking lead. So I will discuss more about it. What is the role, and when at what stage this data domain knowledge or the business information will take lead when we talk about data science life cycle. So going forward, let's try to understand another big word which is in there: extract knowledge and insights. So when you say extract knowledge and insights, what is that? So that is task in hand. So when you solve a problem, one or more outcomes are expected, or you are working towards one or more outcomes after that problem solution. So let me give you an example of search engine, Google search engine. So if you start typing in Google search engine data science CAR, so you see a list of predictions which are coming at the down: data science career path, data science car, data science career in India. Though I am not written anything like career in India or career guide or career growth, you will see that. So in this case, when somebody is developing search engine and using machine learning algorithms to give you some of the predictable outcomes which you may would uh, you may be interested in exploring. So when you write data science CAR, so this search engine is not aware what you are looking or looking forward to have in this, but search engines tries to give you some of the predictions that you may interested in. So that's what search engine is, and the outcome is expected here, that before you complete your statement or sentence, typing your statement in that, you get a list of predictions of options which search engine is giving. So another example at the bottom, left bottom, is object localization or object direction. In the image at the bottom, you see that there are many objects in that image. That is, there are two persons sitting on a bench, there is one cycle, there are two people walking on the road or crossing the road, and there is one person who is riding the cycle. So here the task is to detect objects which are moving. So if you see, there are three objects which are moving. There are two pedestrians. There are two persons who are crossing the road and one person who is actually crossing the road. So that is another data science task. And here outcome is expected to detect moving objects in that object. Another example is social network analysis. So these this Facebook, Twitter, all these social network sites, they do social network analysis. And very important application of this you can take as, like, if you have a friend circle of 20 people, and one person is using one specific product, and now if there is another company who wants to launch their product in the market, and they can actually use this graph and see. Now in the graph you see red and black, red, blue, yellow, green, circles, which are actually people. And the size represent here is the how strong that person in this network, or number of connections that person has in this network. So simply the new product or the company which is launching new product will target the bigger red person dot uh, to influence that. If that person is using their service or product, definitely more people will come to know about that product or the service. So this advertisement of that service or the project product becomes automatic. So just looking at the social network analysis, people or the companies, strategize their advertisement policies or advertisement schemes. Another example is in healthcare, that is cancer classification. So looking at those images which is coming from scanning the body and detecting the cancer tissues, cancer cells, cancer tissues, and localizing that. So another good example is predicting election results. So when a person tries to predict election results, so he actually uses data science, and at the back end he is using actually many features like geographic, social, economic, status of that geographic, opinion of people about a particular leader or a political party, and then after analyzing those data he is coming up with a some predictions. So election results predictions. So going forward, let's look at what is the other term or the other word which is very important in this definition of data science, that is the structured and unstructured data. So when we talk about data, so data is anything, any information which you can use to predict something. So when I say information, that can be organized in a very well way, in a very good format, like structured data. So giving you an example of Excel spreadsheet. So in Excel spreadsheet you have columns and rows. So if you look at the column and just try to use that column as a gender column, and in the subsequent rows you put male, female, others, all that categorization of gender, and the next column if you use as a age of that person. So if you use, like in the first row, if you put 68, that is the age of the person who is a male in the previous column. So in that way what would happen, this male, the gender in the second row, in the second and the first column will be associated with the second row in the second column with the age, that 60 is 68. So there is a one-to-one correspondence in the entries, so that is very organized. So that kind of data, when you put in a tabular form, is called a structured data. And there is another kind of data which is unstructured. So these days we are using a lot, like a very good example is images. So these days we are using images in many data science problem to come up with solutions. So when you look at images, so there is no structure in the images. So if there are people walking, there are buildings, there are trees, all that, there is no structure in the data. So that is why it is called unstructured data. So other examples: emails, social media messages, and PDF documents and videos, all these files, these are under unstructured data. So you can use different kind of technologies or algorithms based on the structure, based on the categorization of data, whether it's structured or whether it's unstructured data. So moving ahead to explain you another important state or words which were given in the definition: scientific methods, process, and algorithm. So when we talk about this method, process, and algorithm, let me show you a typical data science life cycle. So what happens when we start thinking of using data science in solving any business problem? So it starts from here. So when we have some business understanding, and when we say business understanding, we have a good understanding of what kind of problem we want to solve. So giving you an example, I'm just giving an example. Like assume the problem here is to arrange grocery items versus clothes in any retail store. So what is the right way to put groceries or put clothing, so that so that people gets attracted towards a certain things when they enter this retail store. So when we start this data science problem, we brings in a business understanding what we want to achieve through solving that problem. So then we go ahead with collecting the data. So collecting the data is under data acquisition and understanding. So we try to find out what are the data sources and what kind of what would be the right pipeline to collect that data, whether it would be like the live kind of, if live data, like if somebody is entering and there is some person who is actually interviewing that person and collecting the data, or how do we want to uh, uh, process the data, that is data wrangling, process the data in the sense. Now there would be many ways you can collect the data. You can put numbers on a paper like 1 to 5 and ask person to rate on some aspect. So that is one way of collecting the data. Another way of collecting the data, you direct ask those questions, how much they feel satisfied when they enter this store, or when they roam around in this store. So that is another. So, and once you collect the data, what kind of format you want to put in, so that is kind of data wrangling. And how do you want to clean the data, like if there are some missing entries and all that stuff. So that comes under uh, data wrangling. And there are sub aspects of analytics environment. I won't be talking about that aspect here, because presently we are uh, talking about understanding the data science, not the complete application of data science. So when we collect the data and we do some kind of processing on data, so then we come towards modeling. When we say modeling, so we want to use some kind of data science algorithms, data science concepts, to come up with a model which can actually help us in getting the solution. So and when we model, we have important aspect of feature engineering, fitting model fitting, and model evaluation. So those are the actually key things we do in modeling. So here I won't go into detail of this, because when you start studying this subject, data science, definitely you will learn more about feature engineering, model fitting, and model evaluation. So what happens when we have collected data and when we have modeled that data, and we go ahead and deploy in the sense we start using that model and the data to make some decisions. So here is the customer acceptance, or the decision is being accepted uh, uh, by the customer, and here it's the cycle ends. So we start with business problem, business understanding, we collect data, we model that data, and we actually make decision based on that data, or the models. So that is the typical data science life cycle. So coming to again the scientific methods, process, and algorithm. So when we say that, so it's actually execution, and what kind of tools and what are the means available for that execution. So when we talk about this, so there would be many languages available you can use while solving data science problem. R, MATLAB, Julia, Python, all these languages are available, and you can choose any one of these. They have their pros and cons. If I talk about R and Python, they are actually open source. You can use these languages free of cost. Where MATLAB is a license based, you need to pay to get that license and to use that. So there are pros and cons of this all these languages. So as personally I'm using Python, and people use R, MATLAB based on their requirements, and based on their specific specific what do you say use cases. So when it comes to Python, You have different tools available in Python. That is, I would say libraries, NumPy, SciPy, Matplotlib, Pandas, Scikit-learn. So, for an example, this NumPy library is used for linear algebra operations. This matplotlib is basically used for displaying plots and visualization kind of stuff. So there are many such libraries available in R, ggplot and tidy, dplyr, and all these libraries are available in R. And the similar libraries would be available in MATLAB, Julia, all these languages. And data visualization is another important aspect of data science problem. And we have certain tools there. Three of them I have listed: Power BI, Tableau, and Data IQ. These are like kind of commonly used tools when it comes to data visualization. And there are many frameworks available for deep learning. Like from Google, we have TensorFlow and Keras. From Facebook, we have PyTorch and Cafe. From Microsoft, we have CNTK. From Amazon Web Services, we have MXNet. And there are others: Theano, H2O, Chainer. These frameworks are available for deep learning. So when it comes to using deep learning or any machine learning, so what data scientist does is going ahead, choosing one language, and then in that language he goes and explore libraries for different jobs. And when it comes to data visualization, outside of outside of this language, there are tools available: Power BI, Tableau, Data IQ. And when it comes to using deep learning for data science problem, a data scientist uses these deep learning frameworks available. So that is about the process and execution. So I will move ahead with the artificial intelligence. What is artificial intelligence? And uh, one second, give me a moment. So what is so let's talk about cognitive process. So what is cognitive process? So psychological process involving execution and understanding of knowledge, formation of beliefs and attitudes, and decision making and problem solving. So we human are very good at it. So when you look at some image or any picture, or assume you are looking looking at some road, and there is a one truck parked there, and just behind that truck there is a tree. So what this cognitive process we do is, like, we when we look at that scene, so immediately we decide what kind of tree, it's a banyan tree or it's a mango tree just behind the truck. And the truck, whether the truck inside the truck driver is sitting or not, and whether this truck is moving or is just parked. So those kind of decisions we make very quickly, and we are very good at it. So uh, here thinking process, or the point which I'm trying to drive is, can computer systems do it the way we do? So we perceive some things in a certain way, like image. So can computers also do that? So that is all about artificial intelligence. To make this happen, can computer systems perceive all these things the way we do, like speech recognition, computer vision? So when we talk about artificial intelligence, it's about simulation of human intelligence behavior by computer system, like learning, reasoning, self correction. And very good example of artificial intelligence is autonomous car or self-driving car. So when people are developing self-driving car, so they are making it so intelligent that it can actually communicate with the environment. So if there is some car which is going before it, what kind of distance is maintaining with that, and if that car is suddenly stopping, whether this car, the self-driving car, is able to detect that and take a decision of stopping it. And when it comes to turn or reading road signs like parking, stop, or maybe signals. So all these kind of we human are very good at it, like reasoning. Like when I see red light on the signal, sorry, I stop my car. So that kind of intelligence people are trying to build in these cars. So that's why it's called artificial intelligence, and it's the simulation of human intelligence behavior in that computer system. So that is all about artificial intelligence. So when we talk about artificial intelligence, so there are two aspects which comes under artificial intelligence. One is machine learning. So what is machine learning actually? I will go ahead with standard definition given by Tom, and we will try to understand what this machine learning is as per this definition. A computer program is set to learn from experience E. Experience, when I say experience E, that is a historical thing or historical data or the historical events with respect to some class of task. When we say some class of task, that is task in hand or the outcomes we expect. Like now, if I take an example of car, so the car should stop after seeing the front car has stopped. So that kind of with respect to some class of task. And performance P, if performance at task T as measured by P improves with experience E. So in a very simple language, I would say that if performance is improving with the increase in the data collection in the past. So what happens that when I gave you an example of predicting your expenses in the month of November and December, so I considered we considered two scenarios where we didn't have data, and another was we have plenty of data, like beginning from November 2018 till October 2019. So there we said that for performance at task as measured by P improves with experience E. So the performance or the prediction of expenses in the month of November and December definitely will improve with the availability of the data. So that's what this definition says. And another thing is these machine learning programs adjust themselves in response to the information or the data they are exposed to. So definitely if there are two different kind of different kind of problems you have in your hand, and you try to expose the same data to different problems, definitely that's not going to work, because every problem would need a certain kind of data which will actually help in learning of that machine learning algorithm. And these machine learning algorithm always try to minimize the error in decision made. So assume I make a machine learning algorithm which can actually predict the expenses for November and December month. And what happens that if I want to improve that, the only way I can improve that algorithm is when I have the measurement of that error which I'm making in predicting. So assume I predict my expenses in the month of November is 35K. And when actually November came and I happened to spend 50K in that month. So what would happen that the error which was 50K in that prediction, this machine learning algorithms will try to reduce or to minimize that error in decision made for the future. So these machine learning algorithms takes that error term in the account to improve in the future. And on the right hand side, we see that what machine learning is and what kind of different problems we cover under machine learning. So on the right hand side we have supervised learning. So it's supervised learning means when you have kind of data which has some labels associated with that. So when I say labels, so you have October month data and other other information about that month, that how many family members were present in the month of October in house, maybe two, and the label date. When I say label, what was the actual expense happened in that month? And in the previous month, if you look at, assume you had three members at home, and what was the expenses happened in that month. So when you have X and Y both in that problem, it is called as a supervised learning. So, and there are many uses of this. Is one of the example is weather forecasting or market forecasting, population growth predictions. So these are kind of supervised learning predictions, and that supervised learning can be used in classification task also. When you have two images in which you have some certain kind of plant, and in another image you have another kind of plant, and you want to detect what kind of plant the image first has or the image second has, then it's a classification problem. And while developing this machine learning algorithm, you have data associated with those images. You have certain number of images of one plant and certain number of images of another plant, and you have specially mentioned that this image has this kind of plant. So that is kind of supervised learning, where you in the historical data you say that this kind of expenses happened or this kind of plant this image had. Another kind of machine learning branch we have here is unsupervised learning. So where you don't have any label. So I will just give an example of like when a clothing or the t-shirt or shirt manufacturing company manufactures or making shirts or t-shirts, and that company is not aware of what kind of size will fit into small and fit into medium in this geographic area. So in that case what happens that uh, company tries to segment or cluster this kind of population in that geographic area to target what kind of batch size that would be looking in the different sizes. So assume like this geographic specific geographic area have percentage in terms of, like after clustering they get to know, okay, maybe we should be for this geographic area we should be targeting 50% of our batch size of manufacturing is medium, because when they cluster this population here, they figured out that the 50% of population is in the medium size. So here the decision was about the batch size of the manufacturing in the geographic area. So there they use unsupervised learning and try to cluster, make cluster of the population to get to achieve that outcome. And there is another is recommender system, where you try to get views from the people and tries to recommend uh, more product based on their previous experience or previous preferences. Then it comes to another branch is reinforcement learning, which is about is like decision is used for some next action. So the decision which is being made through this is used for the next action, like robot navigation. So that kind of branch deals with robot navigation problems. So this is the overall view of machine learning. So we go ahead with deep learning. What is actually deep learning? So why this term is coming, and what is all about? What is this deep learning all about? So on the left hand side, you are seeing a picture of our brain neurons. So so this deep learning is actually biological inspired by human brain. So we'll just talk about a little bit about this human brain, how does it work, and then we'll take this concept forward to deep learning. So on the left side image, you see there is a neuron in our brain, and there is a receiver which is called dendrites, which receives signals, and there are transmitters which are called axons, and these actually transmits the signal. In the short, in the small box, you see that there is a signal being transmit through synapses from transmitter to the receptor. So what happens that this the same concept, that passing on the information was brought in here when we talk about artificial neural network. So what we say here is that these are the neurons which are artificial, not actual brain neurons, but artificial, and they tries to model the neuron in a biological brain. So if you look at the small picture, this is small picture of neural network where these circles are, neurons, and all these circles are connected with each other and tries to pass on the information which actually helps us in deciding or making a decision at the output stage. So coming back to deep learning, what is deep learning? So that is the class of neural network algorithm that uses cascade of multiple layer of non-linear processing units for some transformation and to help us in making a decision at the outcome, at the output. So there are many different uh, deep learning techniques: feed forward neural network, convolutional neural network. The feed forward neural network are used to predict a regression kind of in regression kind of problems. The CNNs are used in image processing task, computer vision task, and recurrent neural network are used where actually the of sequence or order of the data is very important, like time series analysis, or you can say speech recognition, or the natural languages processing. These are the areas where recurrent neural networks are being used. So here we end our first section of understanding data sciences. So next section would be career in data sciences. So before we go into career in data sciences, let's take a break and try to answer some of the questions if audience has here. You can post your question or clarification in the chat window. Any question here? Okay, we'll move ahead to career in data science. So when we talk about career in data science, So data science is everywhere these days. So you consider energy sector, finance, hospitality, government, healthcare, insurance, manufacturing, pharmaceutical, retail, telecom, and list goes on. So these days, every industry or every sector is trying to make use of data and trying to get insights or improving their decision or the strategy of how this sector should or their company should be growing, and all these decisions are being taken based on the data. So data science is everywhere. So what I will do here is I will just go ahead and discuss some of the sectors here, and what these sectors are expecting from data science, and how data scientists can help organizations in achieving these goals. So let's discuss finance sector. So when it comes to finance sector, there are banks, wealth management companies, stock market, cryptocurrencies. So these are the organizations which are actually looking at data science to help them in making decisions. So when it comes to success of these organizations, there are things which there are keys to success, like risk management for finance sector, company security, trustworthiness, and strategic decisions. So another key to success is fraud detections, because these days what happens that there are many transactions which are fraud. So whether banks are able to detect those fraud transactions, or maybe when it comes to launching new product to the customers, how can how can banks or other sectors can personalize those offerings for enhancing their profit. So assume they launch a new scheme, and under that scheme they want to target certain sector of middle class. So what happens that they use information about their income, their salary, their expenses, and their risk appetite, all that kind of information they use, and they personalize that offering to that sector or that segment of customer. Then it comes to stock market forecast, portfolio management, cryptocurrency. So these are the some tasks or the expectations which banks, wealth management companies, or stock markets have from data science. So how data scientists are fulfilling these expectations. So, or we can say that data scientist job. What are data scientist job in this sector? So, automated risk management system, tracking unusual financial behavior, using natural language processing or data mining or text analytics to process the information about customer sentiment analysis techniques, which are actually very important to generate insights of client behavior, trading algorithms to forecast market, or blockchain technology. So these are some tasks which data scientist tries to do, or the data scientist does at this organization to make this organization successful. This is about finance. Now when it comes to manufacturing, healthcare. So healthcare has a very big role to play when it comes to using data, because most of the time healthcare sector is dealing with life of human or life of animals. So what happens in that case is accurate interpretation of medical images or detect tumors, then genetics and genomics. When it comes to drug creation phase, the data used here is enormous, and uh, these decisions are driven by totally based on data. Then these days you are seeing that companies are coming up with real-time monitoring of health, that is healthcare mobile apps that performance and enhance their health. They give like some kind of your sleep pattern, your heart rate and all that at in live, so that you can monitor your health at certain point of time. So what data scientists, what kind of role data scientists are playing here? Again, automated accurate information through image analysis, deep understanding of genetic issues in reactions to particular drugs and disease, initial screening of drug compounds, the prediction, sorry, to the prediction of success rate on biological factors. And when it comes to healthcare, so due to advances in technology, we can now collect most of the data related to human body, like heart rate, sleep pattern, all that stuff. So when we have this kind of data in our hand, so machine learning algorithms can be used to detect and track more common conditions like respiratory diseases and all that. So another very important good use case of data science in healthcare is improving diagnostic accuracies and efficiencies. Though we have very huge amount of health data, but still our diagnostic failure rate are high, and data science is actually helping us to improve on that. And another aspect, when we talk about this data science in healthcare, is extraction and analysis of biological samples from thousands of patients using powerful machine learning algorithms. So I will give you one example. Here is there is a Boston based startup, that is BRG Healthcare. So using very strong machine learning algorithms, they have come up with a drug BPM 31510, which is actually helping cancer patients a lot. So healthcare sector is actually uh, using this data to a larger extent to come up with different innovation and monitoring health, diagnostic capabilities or cure capabilities of diseases. So, and going forward to insurance sector. So, what is insurance sector is doing with data science? Price optimization, fraud detections, again, personalized offerings, customer segmentation, calculating lifetime value predictions or claim predictions, so that they have have a very good clue about what kind of premium they should be having on price optimization problem. So here, what data scientist does is historical cost, expenses, claim, risk, and profit, and projected in the future, tracking unusual financial behavior, then coming up with personal offerings using natural languages processing to get correct information, and then customer segmentation based on their attitude, preferences, behavior, and personal information. These were in the insurance sector. So what is there for data science in manufacturing sector? So in manufacturing, if you look at manufacturing sector, they have predictive analytics, fault prediction and preventive maintenance, demand for forecasting and inventory management, price optimization, warranty analysis, quality control. So how data scientists are helping in manufacturing sector? So predictive analytics is to forecast the present data to get the health, the information, or the predict health of the machinery. And can you come up with a strategy of maintenance based on these forecast? Or computer vision application, can you look at different products and come up with a come up with a criteria of failure of those products based on image or computer vision analysis. Can you make your factories digital, or can you help factories to optimize resource utilization? So these kind of things where data science is helping manufacturing sectors. Going forward to retail sector, so retail sectors, like retailers reach to customers, customer behaviors prediction, basket analysis, warranty analytics, again price optimization, inventory management, location of new stores, or lifetime value prediction of the customers. All these are things which companies are looking at to make use of data and come up with strategies. So how data scientists can help retail sector in that? So recommendation engines, or again looking at the customer's profile and then using natural language processing to give them a personalized experience. Then again customer segment, uh, grouping those customer based on their spendings, their earnings, their salaries, their attitudes, all that stuff. So these segmentations, segmenting this customer actually can help uh, retail sector a lot. So going back to refinery or the energy sector, so key to success would be these drilling and exploration process in this sector is very important. And how can a company can save on these operations, or how can they increase the efficiency or productivity of this process, and or can company predict accidents or failure of the machines, uh, or maybe avoid power outages. So these are the some tasks like planning better maintenance and repairs. These are the some important tasks which actually company tries to look at when it comes to refinery or the energy sector. So data science is again playing a big role here. We have like people are developing machine learning algorithms or analytics to improve efficiency of refineries or the machineries or the process here. And now predicting part failures and remaining useful life or reducing downtime of machineries are the task which actually data science is helping in this refinery. So I have talked about some of the sectors, but you will find each and every sector these days are using data science to maximize their profit and maximize their market share through the data. So with this slide, I end a second section of this webinar, which was career in data science. So if you have any questions, you can post your question on this forum, and team will get back to you on the with the answers. And again, I thank you all for joining this webinar, and I thank you Equation for providing this platform, which is actually driving a big push towards making making engineers to choose data science as a career. So thank you all again for for your participation.